Hello everyone, my name is Shay, and today I'm going to be bringing you all a tutorial on how to use the SolidWorks to URDF plugin to convert a SolidWorks file to a URDF file without having to write any URDF file code by hand. And this is going to be good if you're trying to import a URDF file into ROS, which is what I was trying to do, and more specifically, in my case, I need a combined visual and collision URDF file for MoveIt and ROS. So if that's what you're looking for, this is a tutorial for you. So the first thing you're going to need to do is define a global X, Y, and Z coordinate system. And the way you first do that is by defining a global X, a global Y, and a global Z axis. And the way you would do that is by first using some plane geometry. So let's go into assembly. Go over to reference geometry, go over to axis. Now we want to define an XY and a Z plane. Selections, make sure this is highlighted, and then click on an edge. You're just looking to click on a singular edge to define your X axis. So in this case, I'm going to select this edge. So you can see there, we clicked an edge. Click OK. And I'm going to come over here. You can either right click and then rename it. There's usually an option in here somewhere. Rename tree item. I'm going to call this global X axis. And one thing that's really important with regard to URDF file and with regards to just making a URDF file is you want to make sure all this stuff has no spaces or special characters. Okay, so then you want to make the y-axis. Actually, while I'm at it too, make sure you name every link should have a name, like a logical name as well. So in this case, this one's base step, this one's link 1 step, link 2 step, link 3 step, etc. Whatever makes sense to you, but just keep it consistent throughout. So let's see. So axis. So now we're going to do our y-axis. So I'm going to call this my y-axis. Click OK. My global y-axis. Let's rename this guy. You can also just double click here usually. Click once. There we go. Global y-axis. Cool. Finally, we're going to do the same for G. So we're going to reference. Find an edge that represents our z-axis. Click OK. And I actually would recommend renaming these for later on. As you'll see, it makes your life much easier. So I would not consider, I would definitely rename these. Don't just leave them called axis 1, axis 2, axis 3, etc. Alright, so in this next step, we're going to add a global coordinate system. Now, to make a proper URDF file using this plugin, we need 3 things. We need a global coordinate system, one defined separately from, say, the SolidWorks global coordinate system. And so that's number 1. Number 2, for every joint, we need an axis that runs through the center of rotation of that joint. And number 3, for each joint, or for each link, for each link, we need a coordinate system at the center of rotation that runs through the axis I just mentioned, somewhere along that axis. Somewhere along that axis, through the center of rotation, we need a coordinate system for that link, and that will be the local coordinate system for that link. So those are the 3 things we need. So first, let me show you how to make the global coordinate system. Now, first of all, let me say too that the coordinate systems in SolidWorks are kind of funny. So they work, but I'm not sure. I'll explain. I'm not 100% certain there's a little bit of funniness going on with them. That's what I'm trying to say. Again, I would make sure all your geometry is fixed, because these coordinate systems, I'm not 100% sure they'll update if you move the links around properly. Okay, so to create a coordinate system, you just go into the Assembly tab, Reference Geometry, and then you click on Coordinate System. As you can see, it's added a new coordinate system here. And just by default, it's gone to this point here, which is actually where I want it to begin with. I think this makes logical sense for my global coordinate system. Again, that's what I'm trying to make right now, is a global coordinate system. To use it, if you want to change your global coordinate system, just make sure this selection box is selected and it is blue. And then you need a point, and you need to select a vertex for this coordinate system. So if I click here, for example, it'll move the coordinate system there. If I clear this, right click and clear, I choose a different point, it'll move that coordinate system there instead. Okay. You can also make your own point and then use that to create the coordinate system. So if I go to point here, I can, for example, select the center of face, which is the most useful one. Select this face center, and we have a point there now. I hit OK. And now if I go back to reference geometry, oh yeah, so that point again is also under the assembly reference geometry. Right next to coordinate system is where the point is. So now if I go to coordinate system, it'll automatically select that latest point that I made, because that point was automatically selected by SolidWorks, as you can see. So when I go to reference geometry coordinate system, it selects that point, and I click on, and then it automatically puts the coordinate system at that point. So that's another useful tool we'll be using later on. But for the time being, as you saw, it actually put the coordinate system right there, which I liked. So I'm just going to do it again, because I actually do want my global coordinate system to be right there. So now we want to align the coordinate system, and this is where some of the funniness in the coordinate system comes in. And I'll be honest, I don't 100% understand why this happens, but I'll show you. So anyways, the reason why I made that X, Y, and Z axis is, first, is to make sure we align all the coordinate systems in a consistent way. So if I, under X-axis, I select the X-axis box, I go global X-axis, I select the global X-axis for the X-axis option, and then Z-axis, I select global Z-axis for the Z-axis option. And then I'm gonna, because I don't want the colors here, the red, the colors correspond to the trident here. Not trident, there's a specific name for it, I don't remember, but the colors correspond. So my X-axis is not going the way that Z-axis, I would prefer to be going straight up and down. So I'm gonna hit this little button to flip the Z-axis direction. So that's good. That's okay to me. So I'm gonna hit OK. Now the thing is, I don't fill out all three, and again, I don't have a perfect understanding of this. It seems like when I fill out all three, it just kind of does whatever. It only seems like you need to put 2 in here to be okay. Hit OK. So that's my coordinate system, my new global coordinate system. So let me rename this real quick. Rename tree item. Global coordinate system. Again, I would absolutely rename these. It'll help you out for some of the later steps. So I would not consider the renaming of these things to be optional. You can see also it hasn't updated, which is weird. There we go. Now there's some funniness here. Let's see if this happens if I open this again. Oh, well, this time it worked. Sometimes it's really weird. You know, what I did there is, for example, if I right click and then go edit feature on this coordinate system, sometimes it'll actually lose these axes. Like you'll reopen this up and then it'll say my global X-axis selection will be gone, or my global Z-axis selection will be gone. And it'll still seem like it's in the right position and everything, but for whatever reason it'll just be gone. And I don't know if that's just something I'm doing wrong here. It never seems like, when it seems to automatically deselect these, it doesn't seem like it actually affects the coordinate system itself. Again, that's one of the reasons I'd say keep everything fixed, because for whatever reason this stuff disappears, and then this still seems to be okay. It's never caused me a problem before, but again, maybe that's just a general another SolidWorks glitch, just the general glitchiness of SolidWorks. But it never seems consistent like just now. I tried this before I recorded this portion, and some of these would disappear. Sometimes they wouldn't after I selected them. So I'm just going to chalk it up to the general glitchiness of SolidWorks, or I could very well be missing some step or doing something wrong there, I guess. But regardless, we have our general coordinate system there. Our global coordinate system, which is good. So now we are going to switch over and we're going to make an axis for our first joint. And our first joint is the joint that rotates this robot arm left and right in this fashion. So to do that, I'm going to put an axis right through this joint right here. Actually, you can see the joint. It rotates the robot arm around that joint. So let's put an axis in there. So go to Assembly, Tab, Reference Geometry, Axis. Then select this. I'm going to select this circular face here. It's better to select faces with, just by convention. It's generally better to select faces in 3D geometry for axes than just to select a circle. So there we go, selected an axis. So I have that axis. And I'm going to call this is going to be my joint 1 axis. So let's rename the tree item. Joint 1 axis. Okay. And also I am renaming these. I've come back. I've actually finished all 3 parts of this tutorial already. I'm just coming back and refining some of the explanations I didn't like right now. So I don't know actually if this name might actually be different, slightly different from the names I use in the rest of the tutorial, but it's the same thing. Maybe I add an extra underscore or something. I don't actually remember. But definitely call this in some fashion joint 1 axis, no spaces. Again, all this stuff, you don't want to have any spaces. You don't, because the URDF file will not like that, and the plugin will not like that. So no special characters, no spaces. That's what you want to do. Anyways, name the joint 1 axis. Because this will, you want to name this because this will make it easier when you're actually using the URDF plugin. It will save you a lot of time. So joint 1 axis. So now that joint, this rotating joint, has an axis, which is good. Now we want to make another coordinate system for this axis. Coordinate system for this link, actually. Oh, my bad, not for this link. We're going to make it a local coordinate system for the base link. So what I'm going to do now, and actually I want to put my base link coordinate system, I'm going to put it at the bottom face here in the center aligned with this axis. That's just kind of what I'm going to choose to do. So I'm going to make a new point, and I'm going to make it as a projection from on this face through this axis. So I'm selecting a face and an axis in this case. Okay, never mind. Intersection. There we go. So I wanted it to be at the center of this arc here, or the center along this axis, but at the center of this circle here. And at least that to me just seems convenient. Okay. Now I will go into my reference geometry, coordinate system, and as you can see, it automatically puts a coordinate system on that point, so just use the point tool. And I also don't usually rename the points because that's not too important, so I'll just leave it as 0.2. And my x-axis, I'm going to select the x-axis, I'll choose the global x-axis, and this is what I always do, which seems to work, is I always select the x-axis, and I always select the z-axis. So I'm going to choose my global z-axis that I made earlier. Boom, there we go. And again, the z-axis is now facing the wrong way. So I'm going to flip the z-axis. So now it is consistent with my other axis there. And again, I don't actually think you have to be consistent in aligning the axes. I'm not too sure, to be honest. But I would, just to be on the safe side, I would definitely try and get them all aligned. And that's what's worked for me. So now let's check that, actually. So we got that. I'll save it. Let's update it. Now let's see if it's actually giving us any funny business here. Nope. Huh. Okay, so I guess when I'm recording, it doesn't do anything funny. Maybe it's because I'm actually updating it. I wonder if I didn't rebuild it, if it would. That's something I was doing differently just now. Maybe you have to rebuild it after putting this coordinate system down if you don't want your features to disappear. But again, that's weird because it's only the coordinate system thing that has that issue. So again, I guess that's just the general weirdness of SolidWorks sometimes. All right, so let's rename this. So this will be our base. Yeah, base link coordinate system or joint name. Actually, I don't remember what the problem is. I don't remember what I named this in my other. I'm gonna call it base link coordinate system. Pretty sure I named it something like that. Okay, let's rebuild it, make sure our name's good. Cool. So that's that. So that is what you have to do for every joint and every link. So now I will do one more example. I'm going to do an actual joint on this robot. Let's do this one right here. So this one would be for a joint. This would be link 3, base link. At least my convention, I'm calling this the base link. This will be link 1, link 2, link 3. That means that, so this is joint 1 here. This is joint 2. This is joint 3. Okay, so let's quickly do this as another example. So I want to get an axis through the center rotation here. So to do that, I'm going to make this invisible for now. Make this part. Okay. Go to reference geometry, axis. Put an axis right there. Rename this to, again, this is an axis. So the axes, I would name them all joint, underscore blank basically. So in this case, this is the joint 3 axis. Okay. So now we need a coordinate system. And we probably need a point first. So put a point. Oops. Let's go point. Center of face. Now we're going to center this face here. There we go. Click OK. Putting it there because I want my coordinate system to be on the face of this little thing here. Again, for the joints, it doesn't really matter where your coordinate system for each link is, so long as it's along that axis for the joint somewhere. So as long as it lies along this axis, anywhere it should be okay. Coordinate system, okay, there we go. It's in the right spot by the looks of it, yep. Now let's just get it aligned here. So again, I would make use of this little drop-down menu on the right here. It's very helpful. So the x-axis, just hit this little black triangle to drop this down, and let's get the global x-axis selected. Select the global z-axis. I'm going to flip the global z-axis. There we go. So now it's aligned with my other two. I'll click OK. So now just to check again, let's see if I open this. Aha, there we go. So as you can see, the x-axis just disappeared for whatever reason. This looks okay, but my axis disappeared. So now let's try this again, but I'm going to reselect this axis. Again, I've not selected this in the past, and I just left it as is, and it seems okay, but that's not really a good thing, so reselect, hit OK. Now I'm going to rebuild it. Maybe that's a trick. So I guess after you put down a coordinate system, just automatically rebuild it. And now it's going to, nope. Okay, that's weird. Again, I don't understand this. I'll be honest. I don't know if this is me not doing something right, and putting the y-axis in there has not helped me in the past, like putting all 3 in. And you should really only need 2 to define the coordinate system. But I don't understand this. I'll be honest. Sometimes it works, sometimes it doesn't. So let's name this link 3 coordinate system. So the coordinate systems you want to name after whatever link they're a part of. That'll make it clear later on. So my base link coordinate system, then I have my link 3 coordinate system. And that's okay. So that's it. So you do the same process. Actually, let's just double check that thing I was talking about here. Will it disappear? Yes, it will. And I don't really know what the deal with that is. So let's bring back, you can see it's still all aligned with my other coordinate systems. So that's okay. Oh, and by the way, if these coordinate systems aren't showing up, like you make one and then another disappears, go into your view settings. So under view in the toolbar at top, view, toolbar, or sorry, hide show. You can choose what to see and not see. So if it's working with these axes, make sure your axes are enabled. Make sure the coordinate system option is enabled so you can actually see it. And then if you want, you could also make the points enabled, but I don't usually do that. And you can here also select anything else that you might want to see. That's it. But yeah, for now, I just want my axes enabled and my coordinate systems enabled. Okay. So what you want to do is go through, let's make this visible, show components. So what you want to go through now is do the same process, put an axis and a coordinate system, put an axis for every joint, and through that axis put a coordinate system for every link. And you do that for every link on your robot. I'm not going to do show every link here, me adding every axis and every link to this robot for the sake of time, but that's what you do. And then also, I would say stick to my naming convention. This will make it easier later on. You need one global coordinate system somewhere in your model, and then name your axes after which joint they refer to, and name each coordinate system that isn't the global coordinate system. Name that after whichever link they are with respect to. Because again, in the next part of this tutorial series, when we start using the actual plugin, this will make your life so much easier. So now I'm going to show you all how you can make your own collision files for your robot. As I showed a little bit in the intro, this is what my robot looks like with the collision files visible. So the orange bits are actually my collision files. So let me show you what that looks like without the regular visual files in place. So I'm going to so I'll just suppress them for now. It's going to give me errors, but that's okay. Okay, so this is a good example of what a collision file for a robot would look like. As you can see, the shapes are very simple, right? Everything's a box, basically just a bunch of boxes and cubes, because what you want to do is you want to limit the number of faces and edges on the collision files as much as possible. Limiting the faces on the collision files themselves will drastically speed up the performance of a gazebo simulation and also a MoveIt's collision checking functions as well. So this is an example of what a collision file could look like. And really all I did for this is I just modeled some new parts. These are just new SolidWorks parts that I modeled and then imported into the assembly. So I'll show you a quick example of this, of how I did this. I'm going to remodel this little boss extrusion right here, just as an example. Or sorry, I'm going to remodel this, my collision model for my base link here, which is just a little rectangle. And I don't want to remodel. I'm not going to remodel the whole thing for the sake of time, and also I don't want this to turn into a SolidWorks tutorial. There are plenty out there for that, but I'll just share my process here and the one or two tricks I have in this regard. So let's make this visible again. So let me switch over to my tutorial robot. Okay, so this is what I had in my tutorial before. So we want to add a collision file for this base link right here. And kind of what your thought process is you want to create a box or a sphere, depending on the part, that will completely enclose that part using the least faces possible, but would allow, for example, a fairly accurate collision. Obviously, I don't want this manipulator to get into a space where it can collide with this component, for example. So I want to just make a box just big enough to enclose this thing. So let's save it, I guess, since SolidWorks is bothering me. Now, let us create a new part. My kind of strategy for this is not super fancy. I just create a new part in a new window. I'm sure I could create a new part within the assembly, but I haven't been doing that, so I'm just going to do it this way. So I'm a new part, on File, New Part. And all I do, for example, for this part is make a new rectangle. I'm going to do center point rectangle is the fastest. Do that. And then, oh, let's just do this. If we know, check the dimensions. Let's go to the Evaluate tab, the Measure tool, select a face, select another face. Again, the Measure tool is good when you want to select faces, if you can, not edges. That would be a much more reliable measurement. It's easy to, and if your model disappears, here's a trick. You can click this little button and click the view cube up here, view orientation, and then select your, and then it'll bring the part back into view, and you click the face you want to see. But anyways, as I was saying, the Measure tool. Selecting edges, it's easy to select an edge, and if those two edges aren't perfectly parallel to each other like you thought, then you can get a wrong distance. So it's better to select faces. So there we go. So distance 72 millimeters. Let's just double check. So clear select, you select 2, and then clear selection, select another 2 measurements. 72. So 72 by 72, clear measurements. And then see what height. I remember this from before. It's probably like 90. It's right here. Yeah, see, it would be preferable if I could get a face somehow. Let's do this face. 91 millimeters. So I'm just going to say for this purpose it's 90. It can be okay in some instances for your collision models to collide, but I would generally avoid it if you can. So let's see. Before I forget here. Alright, so let's go to my center rectangle. 72, and then I'm going to hit tab here. I'm going to go to the other one, 72. I'm doing this all in millimeters, by the way. Then I go to my features, extruded boss base. This is a 90 millimeter tall cube. Click OK. As you can see, this is a great cube, which would be fine, but in my model, I like to spruce it up a little bit. I want to actually be able to distinguish my visual from my collision model. So what I do is I go into appearances, and then I select a new color. And in this case, I like to go glass, and then which one is it? It's textured, not textured, gloss. There you go. And I select brown glass, so that way, it gives a little bit of distinction. This way we know. There you go. As you can see, it makes it clear. So now it kind of implies that it's a collision model. So now I will insert this part, base collision. I will mate this side to this side. Base goes here. Just doing your standard SolidWorks things, your mating things, and let's flip the alignment. Now the one thing I would recommend at this point, this is one of, if you can, it's very useful a lot of times to do a symmetric mate between two faces. So let's see here. Do we have this is my base link. I'll show you what I mean about that. Here, is there a plane that goes, not the base collision, base link. Do we have a plane that splits right down the middle of this part? Okay, had a bit of an interruption there. But anyways, we need to put a plane between these two guys to make things easier for ourselves. This will make sense in a second here. So if we click on two faces, it'll put a plane right in the middle of the two of them. Say okay. Now what we want to do is use mate. Click symmetric under advanced mates. Symmetric mate. And the symmetry plane is already chosen for us, but this is the right one. Symmetry plane is plane 1. And then click on these 2 faces. They want it to be symmetrical, and boom, there you go. We can see it gets symmetrical. And this is a pretty helpful trick I would use in a lot of situations for creating setting up these collision models correctly. Okay. Oops. In this case, I do just want a standard mate. There we go. And voila. There is our collision box for the Dorna 2, at least one of them. So then I'd use the same process to make a collision model for the rest of the links here. And that's it. So that concludes part 1 of this tutorial. Let me know if this was helpful to you guys. And thanks for watching. In the next part, we will go over how to actually use the SW2URDF plugin, the SolidWorks URDF plugin. So be sure to check that out. See you there.